Hello everybody and welcome to the vlog for Team 11's presentation on the Fizbin card game. So I want to start with saying that all the information has been provided here has been through the assistance of the other groups participating in the Fizbin assignment. In this file, I'm going to tell you about some theories that we have formulated. On how this card game actually works. We've generated three main rules that tend to work more often than not with this card game. And the first of which is the single suit rule. And that single suit rule states that when all four players submit cards that share the same suit, the winner is, of course, the highest card value. Now, the card values are as follows. So we have when the card face shows a 2 through a 9, that the value of the card is equal to the card's number. So a 2 is 2, an 8 is 8. When a 10 is present, its value is 1, which makes it the lowest value card. And then when you have an ace, its value is equal to 10. Now, as far as a jack, a king, and a queen, we currently do not have any information on those, but we are assuming that they could possibly be an 11, a 12, 11, a 13 as well, with the king being the highest, queen, and then jack. So as far as this rule is concerned, we tested it on some of the other data that has been presented by the other groups, and it works almost all the time, except for one particular instance where it did not work. And that was with this data set right here. And that was where the 10 of spades, the 2 of spades, the 4 of spades, and the 7 of spades disproved our theory when the 10 of spades beat. But what should happen with the single suit rule is the 7 of spades should have won, but it did not. And down below, we actually see in this second set of data that the 8 of spades, the 10 of spades, the 2 of spades, and the 4 of spades allowed the 8 of spades to win. Now, these two data sets are extremely similar in the sense that there is both a 10, a 2, and a 4 of spades. The only difference is the 7 and the 8 of spades, so like one value off. So we're actually going to be looking at this to see if there's some kind of anomaly going on. And we want to resubmit the 10, 2, 4, and 7 of spades data set to see if we have any continuity going on with that. But that aside, we actually have the second rule, which is the first player advantage. And this rule can be seen whenever a group submits a data set of only one card, player 1, we see that player 1 most of the time wins. And we also see it in the event of a tie when, for example, in one of our data sets, we had player 1 and player 3 with the same value, and player 1 won that one. So with the amount of data that we have, we are formulating that in the event of a tie, player 1 usually wins. And then we move on to one of our more complicated rules, which we call the multi-suit rule. And this rule states that when 2 or more suits are present among players, different rules start working. And this rule, of course, works on the assumption that the single suit rule is true. So our working theory for our multi-suit rule is the donation rule. Certain card suits can take values from other card suits. And we currently believe that there are two different types of card suits. There is the taker card suit, which will actually take the value from one of the giver suits to increase its value. Now, of course, the giver suit will give its own value to one of the taker suits. And we believe this trend works upward. And that is, so far, that's what we've seen. So the taker suit will actually take from the giver suits below it. And the giver suits, of course, will give to the taker suits above it. So if this rule is actually true, that would mean that player order has importance. So what we want to do is we actually want to test to see if player order has any relevance by submitting a copy of previous data set. Except with the new data set, we're wanting to change the order of the cards. So our main hypothesis is that if we hypothesize that if 2 identical data sets are submitted in a different order and the same result is given, that the player order does not matter. Sorry about that. So, yeah, once again, as I was saying, if 2 identical sets are submitted in different order and the same result is given, and the player order does not matter. Otherwise, it does. And that is a crucial step because a lot of our rules and our speculations are going off the assumption that there is what player order does matter. But until we can decide if player order does matter, we wanted to go ahead and test our donation rule. So what we did was we gave 2 experiments, one of which we submitted the 2 of spades, the 10 of clubs, and the 3 of spades. So what we're hoping to test here is to see if the club and the hearts will donate their value. So going by the assumption of the single suit rule, we should see that the 10 should have a value of 1, but it has a value of 0. So what we can guess from this is that the 10 of clubs has given its value of 1 upwards to the spade, 2 of spades, to create its value of 3, whereas it should be 2. And you can also see this replicated down below, where the 9 of hearts, its value should be 9, is giving its value to the 5 of spades, making its value 14. So with these 2 pieces of data, we can see that there is, in fact, donation happening. And from what we have guessed so far, that the spades are taking the value from the 9 and the clubs. So we summarize that player 1 has won in both of these scenarios because the give suits of hearts and clubs are donating to the taker suits of spades. And the tie between the 2 of spades and the 3 of spades, both having a value of 3, is figured out by the first player advantage rule.